Hello guys, welcome back. In the previous video tutorial, I explained about Booth recoded multiplier Booth's algorithm. There are two ways are there for Booth's algorithm. One is the table method and another is Booth recoded multiplier method. So in the previous video tutorial, we discussed about Booth recoded multiplier of Booth algorithm, that is signed Booth algorithm. The Booth multiplication reduces the number of additions for intermediate results. It reduces the addition of the intermediate results or the partial products, but can sometimes make it worse, as we will see. Because in the example that we discussed in the previous video tutorial, that is a multiplicand value is 21, multiplier is 14, and by scanning the multiplier bit you have to write the Booth recoded multiplier, that is placing a -1 in a string where you see the first one in a string, and placing a +1 where you see the next 0 in a string. So that you have to write the Booth recoded multiplier from a multiplier value. So in this case, Booth recoded multiplier contains 1 minus 1 and another is +1, means one addition operation, another subtraction operation. And that we done this one, we discussed in detail this case. So the worst case with this Booth example is Booth recoded multiplier contains just two non-zero digits, that is one in previous example 1 plus 1 and another is -1, which means that only one addition operation and one subtraction operations are needed for the previous example. So saving is realized for this example. There are only just two operations, so we will feel that this Booth recoded multiplier is the best method. But there is a worst case situation in which a simple Booth algorithm requires twice as many additions as serial multiplication. So in the next example we will see the worst case of Booth example. In this case we consider 14 as multiplicand value and 21 as multiplier, and write the binary for this 14 and 21, and these multiplier and multiplicand, the value should be even sized, even numbers, even values. See, in our case there are 6 digits are there, 6 binary bits, and it should be even. It should be 6 bits, 8 bits, 10 bits, 4 bit, but it should be even. Then from the multiplier, in our case here the multiplier is 21, so here you have to write the Booth recoded multiplier. Booth recoded multiplier, in this case place a -1 in a string where you see the first one in a string, and +1 where you see the next 0, and again 1 is encountered, so write a -1, and again next 0 is encountered, so write a +1, again 1 is encountered, so write a -1, again 0 is encountered, so write the +1. So this Booth recoded multiplier that contains +1, -1, +1, -1, +1 and -1. Here there are this +1, +1, +1, means there are 3 addition operation -3 subtraction operation. In this case there are total 6 operations you have to do. There is no shift operation or 0. But in the previous example, here you can see you need to perform only one addition and one subtraction. So there are just two values are there, and you easily perform the addition that is the multiplication. But in this case there are six terms are there, that is minus 1 into multiplicand is 14 into 2 raised to 0, the position weight. Then here the next value plus 1 into 14 into 2 raised to 1. 2 raised to 1 means here actually they are not, I'm not written clearly, because in the previous video tutorial I clearly explained about these things, the position weight and the multiplicand and the value, the both recorded value into, this is both recorded value into multiplicand into the position weight. Okay, so here just I written this minus 14 into 1 into 2 raised to 0. Then second plus 1 is there, so 14 into 2 raised to 1. Then next minus 1, that is minus 1 means minus 1 into the multiplicand is 14 into 2 raised to 2. Then next plus 1 is there, so 14 into 2 raised to 3. Then next minus 1 is there, minus 14 into 2 raised to 4. Then last plus 1, that is 14 into 2 raised to 5. Here you have to find the decimal value, that is minus 14. Now here is 28 and here 56 minus 56. You have to find the decimal values. After finding the decimal values, you have to find the binary, and this binary here, the as per this value you can see this 14 into 32 is the largest number. So first you have to find the binary for this, and you have to write the binary bits in a multiple of 4. Here in this case there are 1, 2, 3, means the value 12 digits are there. So all the digits you have to make it to 12 bits, binary bits. So if you do the calculation, you will get the result 294. Okay, means it is depend upon this multiplier, the value, the number of steps is increases. So this is the worst case, as the number 6 steps are involved, means you have to, it takes more time, the complexity will increases. So that's why to overcome that drawback, we are going for one more algorithm, that is called as modified Booth's algorithm. So this till now that we have discussed is one way of Booth's algorithm by using the table method. This table method this is called as the table method, and the another method is this way, that is a computing the both recorded multiplier and then performing the operation. In the next video tutorial we will discuss in detail about the one more faster multiplication algorithm, that is called as modified Booth's algorithm. Okay, Booth algorithm is different, modified Booth algorithm is different. Modified means it is a faster compared to this present Booth's algorithm. Thank you.